tendency to attract electrons to itself. You are some neutral atom. How much do you attract electrons to yourself? Not necessarily stealing them totally, but maybe making them come be closer to you. Of these three trends, this is by far the most important of the three as far as your future chemical career. You'll hear about electronegativity a whole lot in 1412. You'll hear about it in organic chemistry. You'll hear about it in biochemistry. Just how greedy is something for electrons. So, the facts. Remember, the facts always come first. What's been found is as we go across, it increases. They get greedier as we go across any period. And as we go down a family, it decreases. So the hot spots, these are the really high in electronegativity. These are the really low. Let's leave the halogens, let's leave the noble gases out of this because they really don't tend to do anything because they got a fine number of electrons already. So they're really not going to want to gain any more or attract more. They're happy just the way they are. So if we leave that out, who's the most electronegative of all? I mean, I want an element. Fluorine. That's the highest of them all. Okay, then who's the lowest of them all? Francium. Exactly, after France. Okay, so Fr down there, so it's the lowest of them all. Usually, your discussion is simply, I've got this and I've got this. Which is more electronegative? So, all you have to do is see who's physically closer to fluorine. So if I say, I've got some arsenic and I've got some sulfur, who's more electronegative? I've got arsenic, I've got sulfur. Sulfur, because it's closer, physically closer to the hot spot. Here's a couple of things to remember about electronegativity. The big three in electronegativity, see, it's almost poetry here. The big three in electronegativity are nitrogen, oxygen, fluorine. When you've had a NOF and a LEF, you've got the highest electronegativity. Okay, that's important to know. That's one important thing to know. And in your book, they have a table. Let me see if I can find it here. There is a table on page 191. And that's not projecting very well because it's shining. But what it has in this table, and I don't want you to use the table, what it has in the table are relative values. It's not really an energy measurement, it's just a relative scale. And I don't know why they built it on the number 4. So the guy that has the highest electronegativity, they gave it a 4 spot. You know, generally you work on a 5-point scale or a 10-point scale. I believe it was Linus Pauling, who was one of the few people to win 2 Nobel Prizes. He won one for chemistry, and I think due to his work on hemoglobin, and he also won for the Nobel Peace Prize, because he was one of the early people going ban the bomb when the nuclear bomb was first built in the early 40s, got out at Los Alamos. He was, by the early 50s, he was a big ban the bomb person, and so he got famous because of that, so he won 2 Nobel Prizes. As he got older, in fact, he lived to be about 95 years old and died within the last 10 or 15 years, he got into health food. And so he was the one advocating you take mega doses of vitamin C, and you would never get a cold, and you would never get cancer. I heard him speak over at MD Anderson, the big cancer hospital, and the MDs about laughed him off the stage because, you know, he was not an MD, and he's telling them, you know, vitamin C will cure all the cancers and will put you out of business at MD Anderson. So, and it hasn't come to be. Okay, so he came up with this chart And you can look there, but you could argue with me when I say, and I don't know how well you can see that, so look in your own books if you have it. If you look up there real carefully, and let me get closer so I can see it, you could argue with me by looking at this. I told you the big three, NOF. Well, he ranks chlorine as the same as nitrogen, but almost anybody will just say it's NO and F that are really deciding factors. So that's one thing to know. When you had enough, highest electronegativity. The other thing, hydrogen is out of place. Hydrogen, you know, sometimes is in this 1A family, sometimes it belongs in the 7A family, depending on its properties, so it's a switch hitter. However, for electronegativity, it doesn't belong either place, and you just have to memorize this. Hydrogen belongs between B and C. So what that means for electronegativity, it's a little bit less electronegative than carbon, but not by much. It's a little bit more electronegative than boron, but not by much. So hydrogen fits in there. So if we had a question, let's see if I can find one here in the chapter easily. Okay, this is 5-5. Electronegativity, I have B, Na, F, and O. And we want to rank these in increasing order, and if you look in my notes, on problem 5-5, this is all you get. Rank them in increasing electronegativity. And you've got a bunch of them. Now, if it asks for just what's the highest of them all, no sweat, because we know that would be fluorine. But because we've got quite an assortment here, let's put them in their relative positions on the periodic table. So, let's see, I've got boron, that's there in the 3A family. And then, let's see, I've got a sodium that's over here and down just a little bit. And I've got, let's see, fluorine here, oxygen here. Okay, so remember your hot spots, the snake works. Okay, so we want it in increasing order. So, which way does the snake go? Or,
right.
Okay,
Left.
it's going to go,
Right.
if we want them in increasing order.